A 300-ton metal tube is falling out of the sky at 280 kilometers per hour. And the only thing standing between you and catastrophe are a few rubber tires the size of a trash can. Now here's the insane part. Those tires don't explode. They don't shred. They don't even flinch. They just roll. After this, you'll never look at an airplane landing the same way again. Let's put that weight into perspective. 300 metric tons. That's roughly the weight of 200 fully loaded family cars. Now imagine stacking all of that on a tire the size of your neighbor's SUV wheel. Your car tire handles about a quarter ton comfortably. An airplane tire handles more than 20 times that per tire. And it does it while going from 0 to over 200 kilometers per hour in less than a second. Not accelerating, spinning up on impact from a dead stop. Think about that. 0 to 200 in 1 second while carrying the weight of a small skyscraper floor. And here's the part that really shouldn't make sense. These tires are barely thicker than the ones on a pickup truck. So how does a hollow rubber ring not just explode on impact? The answer comes down to 3 things: extreme pressure, radical construction, and a special gas. To understand this, we need to go back to 1903. The Wright brothers' first airplane weighed just 275 kilograms. It didn't even have wheels. It landed on wooden skids. As planes got heavier, engineers borrowed bicycle tires, actual bicycle tires, and for a while that worked, until it didn't. After World War II, aircraft became dramatically heavier, and tires started failing catastrophically. They shredded on landing. They burst under load. Heat from braking caused them to catch fire. A single blown tire could destroy landing gear, damage the aircraft, or even cause a crash. Engineers had a serious problem, and the solution came from rethinking what a tire actually is. Not just a container for air, but a precision structure. Principle 1. Pressure. A car tire runs at about 2.5 to 3.5 bar. An airplane tire runs at around 14 bar. That's roughly 6 times higher. At that pressure, a normal tire would explode, but aircraft tires don't because of what's inside their walls. Principle 2. Construction. An airplane tire isn't mostly rubber. It's built from multiple layers of high-strength cords, nylon or steel, woven together at precise angles. These layers carry the load. The rubber is mostly a protective outer layer. It's like a fire hose, flexible on the outside, but incredibly strong inside. Now imagine what happens during landing. The tire hits the runway at around 250 to 280 kilometers per hour while not spinning. For a brief moment, it's dragged across the surface, compressed, twisted, and heated all at once. The surface temperature spikes instantly. That smoke you see when a plane lands, it's not the brakes, it's the tire itself, vaporizing a thin layer of rubber as it spins up. And here's something most people don't know. Aircraft tires aren't replaced every time. They're retreaded. The outer layer wears down, but the internal structure remains intact. A single tire can be reused multiple times across hundreds of landings. Principle 3. Nitrogen. Aircraft tires aren't filled with regular air. They're filled with nitrogen because oxygen reacts under high heat and moisture causes pressure instability. Nitrogen doesn't. It stays stable across extreme temperatures, from minus 60 degrees in the sky to intense heat on the runway. So here's what actually happens during landing. At cruising altitude, the landing gear is stored inside the aircraft, where temperatures outside can drop to minus 60 degrees Celsius. As the plane descends, the landing gear deploys. At around 250 kilometers per hour, the main wheels touch the runway first. In less than a second, each tire deforms slightly, spreading the load across the surface. The contact patch, the part touching the ground, is only about the size of a dinner plate, and yet each tire can handle around 18 tons. The grooves in the tire aren't random. They're designed to channel water away at high speeds, preventing aquaplaning. And there's one more hidden feature: a fusible plug. If the brakes overheat, this small component melts and releases pressure from the tire in a controlled way, preventing an explosion. So here's the truth. Airplane tires don't work because they're indestructible. They work because they're engineered with precision, flexible where they need to be, strong where it matters. Every layer has a purpose. And the next time you're looking out the window during landing, Watching those wheels touch the runway, you'll know exactly what's happening and just how incredible it really is.